Suppose that we were asked to graph the absolute value of x. Well, we might remember from Algebra 2 that the graph looks, if I did a rough sketch, it looks something like this. So basically, it's going to be shaped like a V. But how exactly is that graph obtained? Well, let's think first about what the absolute value means. The absolute value of a number, for example, 5, is asking how far is that number from 0? Well, 5 is 5 units from 0. Well, what if we said how far is negative 5 from 0? Well, negative 5 is also 5 spaces from 0. So let's say that we were to use that knowledge to come up with a graph. So let's say we had 1. We say, what is the absolute value of 1? Absolute value of 1 is 1. Or how far is 2 from 0? Well, it's going to be 2 units away from 0. Or how far is 3 from 0? Well, 3 is 3 units away. So if we kept going, we would end up with this graph. And if you remember your Algebra 1, basically this is the line y equals x. So in other words, on the right-hand side of our graph, we would just have the function f of x is equal to x. Let's say we want to do the left side of our graph. So we have negative 1. How far is negative 1 from 0? Well, it's going to be 1 space. Negative 2. How far is negative 2 from 0? It's 2 spaces. How far is negative 3 from 0? It's 3 spaces. And we can keep going, and we will end up with a graph that looks something like this. So the same graph that we mentioned at the beginning. So what this means is that we could actually think about the absolute value function. We could rewrite the absolute value function as a piecewise function. We could say that if I start off with a function, we're using g here. If I start off with a function g of x, that's the absolute value of x, well, I can really just say that that's the same as saying one of two things. If I'm on the right side of the graph, so in other words, if I'm on this side of the graph, then I'm just going to say x. But if I'm on the left side of the graph over here, then it's the same thing, but just with a negative slope. I'm going to say negative x. So in other words, when x is greater than 0, I'm going to say my function is x. When x is less than or equal to 0, I'm going to say negative x. So in other words, x greater than 0, which is this side, all my positives, I'm going to use the function x. And x less than 0, so all my negatives, this side of the graph, I'm going to use negative x. So in other words, if I give you, for example, the function f of x is equal to the absolute value of 3x plus 5, and I say rewrite this as a piecewise function, then you can say, well, it's really just one of two situations. I'm either starting with the positive version, which is 3x plus 5, or I'm going to have the negative version, which is the negative of 3x plus 5. The positive version is going to work on the positive side of the graph, and the negative version is going to work on the negative side of the graph. So what does that mean for the function that we have here? So this function, h of x, is equal to the absolute value of x over x. Notice that it's a rational function like we've been graphing, But this rational function has an absolute value, so we have to treat it a little bit differently. But to make it look like another function that we already know, we can say, well, I know how to handle the absolute value. I can say that my function is one of two things. On the right-hand side, the absolute value, I can just say x. On the left-hand side, I can replace the absolute value with negative x. So in other words, when x is greater than 0, that I'm just going to replace the absolute value of x with just x. And when x is less than 0, I'm going to replace my absolute value of x as a rule with just negative x. So how do we graph this? Well, it's kind of easy because what's x divided by x? If we rename this function, we're really saying that on the right-hand side of the graph, x divided by x is just going to be 1. And on the left-hand side of the graph, a negative x divided by a positive x is just going to be a negative 1. So on the left-hand side of the graph, we're just going to graph negative 1. So what exactly would this graph look like? Well, we know that we can't have 0 for an x value, so let's just say that we mark that off. We can't have 0 as our x value. So every point on this line, we know for sure can be a number other than 0. So to the right of that, we know that everything's going to be 1. So when x is 1, then y is 1. That's what this rule says. Everything to the right is 1. So, excuse me, when x is 1, y is 1. When x is 2, y is 1. When x is 3, y is 1. So no matter what, we're going to end up with y values of 1. So no matter which x value we have, we're going to have a y value of 1. When this line meets our border, we know that it's going to be an open circle because again, we can't have 0. 0 is not included here. X cannot be 0. We can't have 0 in our denominator. So similarly, down here, when on our negative side, everything's going to be negative 1. So we're just going to have negative 1 all the way across and nothing on our border because again, x cannot equal 0. So this is what the graph would look like. If we were to graph the following, we could use the same scenario. This time though, we want to be a little bit wary because previously we just said absolute value of x. So it was either that x was greater than 0 or x was less than 0. This time it says absolute value of x plus 4. So if we think about it, the contents here have changed slightly. So we're saying either x plus 4 is greater than 0 or x plus 4 is less than 0. If we solve this for x by subtracting 4 on both sides, then we're saying either x is greater than negative 4 or x is less than negative 4. Also, we want to keep in mind that the denominator cannot be 0. So that means that since x plus 4 cannot equal 0, that means that x cannot equal negative 4. So how do we graph this? Well, we're going to have two cases again. Either we replace the absolute value of x plus 4 with just x plus 4 in the positive case. And remember, our positive case, when we solved for it, this time was saying x was greater than negative 4. Or we'll have the negative case where we're just going to replace the inside with just negative of x plus 4. And our negative case was x is less than or equal to negative 4. In this case, when we divide, x plus 4 divided by x plus 4 is 1. A negative x plus 4 divided by a positive x plus 4 is a negative 1. But notice that we're multiplying by 3 here. So we have to remember that we're multiplying by 3. So that's going to change our answer. So either we're going to have 3 in the positive case or negative 3 in the negative case. So our two scenarios are either that f of x will be a positive 3 in the positive case or a negative 3 in the negative case. And in terms of what that looks like, just like on the previous graph, at negative 4, we will have an open circle where our graph meets, or where our graph meets this, this particular line here. So we said that to the right of our line, that it should just be 3, and we have an open circle where it meets. And to the left of our line, we will have negative 3, and we have an open circle where it meets. So this is what our graph looks like.